let's redraw this picture in a way that suggests that we actually know what we're doing. This finite piece looks like this finite piece, right? Suppose. Looks like some finite piece, so I might as well put it here. Then I extend a little more. I add maybe a few billion elements over here. Still finite, so it still looks like this. They're actually the same, right? These are the same thing. If I gobble up all this, I actually eat up all this as well, right? It might be that I keep going, and I never get around to this territory, right? But if everything in here is covered by something in here, then they're actually the same structure. Well, this is interesting. How long would I have to spend to tell they're not the same? Infinitely long, right? I have to go through, check that this isn't covered, still not covered, still not covered, still not covered. At the end of an infinitely long day, I could then determine they're not the same. Remember the no infinite proofs thing? Yeah. There has to be no way I can do that, right? Which means that there's something very much like this guy, where these two things are actually the same structure. Right? Now, random point. Why did I make this all countable? Because otherwise this wouldn't work. I've counted it, see? This is part 1, 2, 3, 4, 5, 6, dot, dot, dot. If it's uncountable, I can't do this part. That's a technical problem. But the idea is if it's uncountable, I might never be able to gobble it up with finite sets. So that's a problem. So now, I have over here my new universe. Instead of m, it has something m prime, right? Looks like n, but might not be the same thing. Over here it's got n prime. Looks like n, might not be the same thing. And between them, still finite isomorphisms. But this time, this is actually equality, right? This isn't just saying they look the same, it's saying that they're equal. This has to be exactly the same as this, as far as L can tell, by compactness, right? No infinite proof means that L can't distinguish these two things. So they're now the same. But I just said L can distinguish between them, right? Contradiction. There's a lot of stuff I'm sweeping under the rug here. There's a whole ton of stuff, exactly how do I make them countable? Exactly how do I employ compactness here to get this? But it's not very helpful. The idea is that I shrink it so that everything's nice. And then I change these structures so they're actually the same structure. But now the same thing is different from itself. Right? And that can't be true. And Lindstromp's theorem is proved. Almost. There's some formality here. Also, this doesn't quite prove Lindstromp's theorem, you need a lemma at the end, but it's a nasty lemma. That's Lindstromp's theorem. Now, the fun part. How the hell can I get around Lindstromp's theorem? It would really suck if this were the end of the debate about logic, right? Because first order logic sucks balls. It doesn't suck quite as many balls as second order logic. Second order logic gets around way more than it's healthy for it, and some people catch sexually transmitted disease. But first order logic has still seen some action. Can't believe I just said that.
I can't. Yeah, you read well. Too strong on that one.
So, Lindstromp's theorem would say first order logic is the best logic. Except you should always be leery of saying that, right? That's a philosophical statement. This is a mathematical theorem. What did I miss? There's a couple things I could have missed. You could be like Skolem. You could say Lowenheim-Skolem actually sucks, and we don't want it. In which case, this entire theorem is irrelevant, right? If you don't want your logical system to have Lowenheim-Skolem, then why give it Lowenheim-Skolem in the first place? Right? And so you can search for stronger things.
What was Lowenheim-Skolem again? Is that
Countableness.
right?
Or, heaven help you, I suppose you could decide you don't like compactness. If you like there to be infinitely long proofs, you could decide you want that. If you do that, you're a dork, and I officially get to kick you in the face. But you could decide that, I suppose. It's yeah.
Dork means penis. Penises don't have faces.
What are we talking about?
So that's one way to get around it, right? Saying the good properties that I said that we need aren't actually that good. 2, this is something that I swept under the rug rather fast. I said, right, I can define what a logical system is. Right? I had to say that, because I'm talking about logical systems. What if I got the wrong definition? It's a very philosophically loaded question. What constitutes a logical system, right? Maybe you say, I didn't get the right definition. In fact, people have said this. There's a thing called independence-friendly logic, IF logic, which is very weird. It has low times goal, it has compactness, it's strictly stronger than first-order logic, and it gets away with this by not being what, according to the formal definition, will be a logical system. In particular, the law of the excluded middle doesn't hold. If I had a sentence A and a sentence not A, they can both be false at the same time, or true at the same time. That's very weird, but it's not completely terrible. There are philosophies that argue that there are statements that are paradoxical, like, say, I am Y, right? True everywhere or false everywhere. That's one way to get around it. Or, this one's weird. Here's the picture, right? Here's my universe of logics. All the logical systems are here. Second order logic is somewhere way up here. First order logic is down here. Here's the set of everything stronger than first order logic. And it's bad, right? That's what Lindstromprt6 says. I don't want to look here. Why not look somewhere in here? Why not choose a logical system that
I
has
don't
nothing?
understand what that picture is representing.
Oh, sorry. This is stronger.
Mm-hmm.
Here's first order logic.
Weaker logic.
Not necessarily weaker. Here's everything stronger than first order logic, right?
By which you mean contains everything from order logic and from law.
Yeah, exactly. First order logic plus other stuff. Lindstromp's theorem says this sucks, right? Everything in here sucks. First order logic is pretty nice, but we already decided for whatever reason we don't want it. We're looking for alternatives. I can look at logics that are incomparable with first order logic. So whatever this is, I'll call it question mark, doesn't contain first order logic, and first order logic doesn't contain that. Maybe I chose the wrong logical system to begin with. Maybe first order logic has nothing to do with what I should be looking for. These things exist, by the way. There's a thing called complemental logic, which is really, really, really stupid, and as far as I know, has no applications. But it's completely unrelated to first order logic. And philosophically, you might decide that it's better. Of course, if you do that, you're wrong, but you might. Peter's going to convince me otherwise someday.
And more importantly, there could be something like that we haven't found yet.
Exactly. I'm not actually current on the abstract model theoretic literature, but there's a lot of stuff that just has nothing to do with first order logic, and which is neither weaker nor stronger. Perhaps we look there. So those are ways you could avoid Lindstromp's theorem. There's another way, though. This way is kind of dangerous. Remember I said this is proven in first order logic, and Hasty got really pissed off?
I didn't get pissed off, I just sort of...
Yeah. If I already have problems with first order logic, why do I believe a proof carried out in first order logic? I could doubt the truth of Lindstromp's theorem, right? If I already have a problem with first order logic, there's no reason I should believe this theorem is true. That gets into some very complicated stuff, though, because there's almost nobody around who seriously advances the position that first order logic is contradictory. Almost. There's a guy named Shapiro. Peter, have you heard of Shapiro?
No.
Okay. Remind me to track down some of Shapiro's papers. He's interesting. I think he's a nut job. He'll probably be found behind a refrigerator with a chicken someday. But he thinks first order logic is wrong, and he's looking over here for some alternative logic, and he disagrees with the proof in the first place. So that's basically Lindstromp's theorem. Done. That went insanely over time.
Well, it was an hour 15 minutes.
No. Expecting before you.
And based on when you actually started, it was exactly an hour.
Yeah, based on when you actually started. Parlay, everyone?
Very quickly before that, word about the next couple TeaRoom seminars. So in order that things be awesome and people want to give talks, the format of the talk is completely up to the person giving the talk. Giving any sort of